Okay, maybe I want to say this first. This is from Spring 20, Math 227, Test 1. Okay, and we work on the whole test. We did some parts of some tests already in the past. Okay, but today for the first 1.5 hour, maybe 2 hours, we will try to make sure that we know how to do one whole set. Okay, and this is from Spring 20. You can find this on the discussion. You can find the blank test on discussion board math to on last Wednesday. So that was on March the 3rd, discussion board. Okay, if you can print it out, that will be great. Otherwise, then you copy the data down or you just attack that right away from here. Okay, and if you happen to have extra time, number 7 is to copy that frequency distribution you get in number 6 and then do the lower class limit, upper class limit, lower class boundary, upper class boundary, and relative frequency. Okay, let's set aside 20 minutes to do this. So we come back I will come back at 4:20 and I will keep my recording on, okay, so that you are aware with the time. I mean, when you take the test, I need you to be aware that you don't want to go too slow, but there's no need to go too fast also. Okay, so I will leave the recording on. It feels like if you are watching this recording, it feels like I'm not doing anything, but that's because I give you time to work on this. Okay, right now it's 4:03. I will come back in 17 minutes. Okay, it's 4:20. You may not be done with your number 7, but I do expect that you are done with your number 6. Okay, the number of points for these questions represent the number of minutes it's supposed to take you to do the problems. Okay, at most. So this one here, even though it's 6 points, then it means at most 6 minutes. Some of them, if you are well trained, then it should take you 1 minute less than that number. So for example, number 1, the median is 2 points. It should take you, if you are well trained, then it should take you only 1 minute to do so. Okay, let's start. It is a population, so capital N, the population size is 47. To find the median, let me find the position first. That's position number 24th, right? Position number 24th is 58.5. Next, what is the mode? So see what is the most frequent data. I think the most frequent data is 85, huh? Don't you think so? It happens 3 times, but is there anything else happen 3 times? Nothing. So yes, the mode is 85. How about the first quartile? They are, the median is on the 24th, the 24th data. So there are 23 data points in the lower half. So 23 plus 1 over 2, the position for the first quartile is data number 12. So data number 12 is 20.5. And data number 12 from above, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 76 is the third quartile. Okay, and the range will be the largest number minus the smallest number, that's 99.5. Let's go on. Construct frequency distribution with 5 classes. So the class with W will be the ceiling of 99.5 over 5. That's, what's that? 19.9?
19.5, so you round to 20.
19 point what?
5, so you round to 20.
Is it 19.5? Hold on. 99.5 divided by 5. I get 19.9. But yes, even if it is 19.5, you still round it to, you always round it up. But it should be 19.9. So I round it up, becomes 20. Therefore, my classes will be the lower class limit of the first class will be 1. So that's scores, and this is the frequency. 1 plus 20, 21 plus 20, 41 plus 20, 61 plus 20, 81. And then this is up to 20, 40, 60, 80, 100. Okay, now then From 1 to 20, how many? From 1 to 20, there are 11. From 20 to 40, there are 6. From 41 to 60, there are 9. From 61 to 80, there are 12. And then from 81 to 100, yeah, I include 105 even though the upper class limit is 100. Is because later on you will see the upper class boundary for this is 105. You see what I mean? Okay, that's the upper class boundary. So right at that boundary, then I still have that. I still have that guy. Okay, so I get this will be how many? 9. There are 9 of them. When I add, let's see, so 17 plus 9, 26, 26 plus 12, 38, 38 plus 9, 47. Do I have 47 data here? Oh yeah, that's right, we have 47 data. Okay, so this is the frequency distribution. Okay, maybe I write a little note. Data point 100.5 can be put into the last class because the upper class boundary is exactly 100.5. Okay, so it is justifiable to do so. Okay, number 7. Number 7, we will copy that frequency distribution in number 6 and we copy that below and we will extend with lower class limit, upper class limit, lower class boundary, upper class boundary, and relative frequency. Let me prepare the stage first. That's the score. And then the frequency. I don't need that much. Frequency. And then lower class limit. Upper class limit. Lower class boundary. Upper class boundary and relative frequency. That's 1 to 20, 21 to 40, 41 to 60. I copy from number 6. 61 to 80, and then 81 to 100. Do a long line here. To get the sum later on, I get 11, 6, 9, 12, 9. 11, 6, 9, 12, 9, add up to 47. Don't forget, always add the frequency. Always get the total of frequency. Likewise, the total of relative frequency also. Now then, the lower class limit for each class, basically the first, the smallest registered number on that interval. upper class limit is the largest registered number for that interval. Okay, while lower class boundary, upper class boundaries is the midpoint between consecutive lower class and upper class boundary. Okay, so this will be 20.5. This is also 20.5. 40.5. This is also 40.5. 60.5. This is also 60.5. 80.5. This is also 80.5. Now then, notice that from the first class to the next class and so on and so forth, the gap is 1, which we divide into 2. That's why we get the boundary is 20.5. Now, which means from the upper class limit to upper class boundary, we adjust 0.5 units. Using that adjustment, we adjust to the left likewise. We adjust, subtract by 0.5. So I will get 0.5 here. And for the upper class boundary, I adjust 0.5 from upper class limit. That's for lower class boundary and upper class boundaries. Okay, I really want to erase this. Now, relative frequency is the frequency for that class divided by 47. By the way, when you write your fraction, please don't write it this way. Please don't write it this way. Especially the worst one, the one I hate the most, is like somebody write it this way. It's like, I don't believe in evolution until I see what you write. You know, it's supposed to be 11 over 47. Now then, some teachers, like around 3 or 4 decades ago, they write it this way, which we agree. Okay, but it's not supposed to be written this way. No. This numerator and denominator not supposed to be the same height, the same line. No. 11 supposed to be on the top, 47 supposed to be at the bottom. So even when you write it this way, it's already not correct. Imagine if your diagonal line suddenly becomes so straight. No, that's not. Okay, that's not. But Thomas, you know what I mean? No, I have one wife. That's one too many. Okay, write it right. Otherwise, don't expect people to understand it. Okay. Yeah. On the other hand, if you don't write it properly, you are inviting other people to criticize you for not doing it right. So why don't you just do it right at the first place and give yourself the right to criticize other people? Okay. Let me say it this way. I don't like people to criticize me. Therefore, I want to do things right. I write things right. Okay. Now, if you are not someone who can do things right, okay, you invite people to criticize you. That's one. Second, you waive your right to criticize other people because you yourself don't do things right. Okay. I think I am someone who don't like to criticize other people in my daily life. Me in this class, in my classes, as an instructor, I have to, because I'm the one teaching you, right? Okay, but in my daily life, I don't like to criticize other people. But even so, I still try to do things properly. When I get into an intersection, for example, and I'm about to turn right, then I turn on my right signal, like around 100 feet prior to that intersection, and slow down. If it is red light, then I stop. Then I roll to the right-hand side if that's safe. Okay. Now, if you try to get people to criticize you and give you middle fingers, then of course you can just like all the way here, and then suddenly you drift to the right like that, no signal. Okay, and then when you hit a cyclist, for example, you come up with all whatever excuses you have. You may even blame the cyclist, saying that that person is riding too fast. If cyclist riding too fast, you must be faster such that you can hit that cyclist. Okay, that's a bad argument. If you don't learn to do things right, you don't see the reason why you have to do it that way. Okay, so let me say it again. Let me say again. Your fraction, okay, your fraction, use horizontal line. Okay, look at all your all calculator in United States. All calculator in United States, the division sign looks like this. That's because a division, basically a fraction, something divided by something. They don't write it something divided by something like that. No, there's no such thing. Okay, the closest to this is actually percent sign, and that's not division. That's percent sign. Okay, a fraction is not written this way originally. Okay, now, even if you want to write it that way, then it's supposed to be not supposed to be the same height. The 1147. Okay, not 11/47. The worst one is 11/47. It's like the line is like vertical line. And then later on, when I do my conditional probability, you get confused. You didn't write things right at the first place. Of course, you will get confused later on when you see somebody doing things right. Okay, I sound like I'm kind of pissed off because I have that in the past. I'm not projecting that to you as if that you are the one making that mistake. No, that's not my point. But I get pissed off with those students that I already say them. I tell them many times, they don't listen to me. And later on, when they get confused, strangely, they get confused with their own handwriting. And I was like, that's your own handwriting. If you don't write it right, what do you expect me to understand? Right? Okay. Imagine if this vertical line gets so short such that it looks like this. I don't know what's that. Okay. Yeah, remember I say that I have one wife, that's one too many. That's just my saying that if you don't say it right, don't expect me to understand it right, even if we are so close as husband and wife. Okay? No. Don't expect too much from me without expecting too much from yourself first. Okay, that's communication though. That's communication. Okay? Yeah, even with me trying to say things right, even with my wife trying to say things right, we still have some miscommunication, but at least she and I both try to make ourselves understandable, right? Okay, please do so too. 6/47, this is 9/47, 12/47, and 9/47. When you add them up, should be 47/47, which is 1. Like what I said before in my class, your relative frequency, maybe you can leave that in fraction, but in practice, either we make it decimal or percentage. Okay? And keep in mind, in my class, the decimal point should be 5 decimal places. Okay? In my class, use 5 decimal places. If the decimal you get is more than 5 decimal places, then round it to 5. Then round it to 5 decimal places. So that's for number 6. Let me go on to number 7. I'm sorry, number 7. Let's go on to number 8. You have seen this so often in my old tests, such that you're supposed to know how to do number 1 to number 9. You should be able to do number 1 to number 9 without stopping, without stop writing. Okay, without stopping, stop to write. Okay, that's X. I need to find the frequency. And then after that, to find the mean, then I need to find the midpoint. This is X subscript I. That subscript, that's not X times I. Don't write it as is, as if that's multiplication. No, that's subscript. And then the first extension, we multiply f times xi. The second extension, we have xi squared and then f xi squared. The classes 1 to 20, 21 to 40, 41 to 60, 61 to 80, and then 81 to 100. The frequency was 11, 6, 9, 12, 9. 11, 6, 9, 12, 9. Okay, then we add them up earlier. That's 47. Now the midpoint. Let me ask you to do this. Okay, we have done this many times, at least 3 times, 4 times. Now I want you to do this again, continue. This should take you around 10 minutes. This should take you around 10 minutes and go on with number 9 once you are done. Okay, go on with number 9 once you are done. That's approximately 3 or 4 minutes. So let's say 15 minutes from now, we start again. So that's 4:56. We start again. Again, I will keep my recording on such that students who watch this recording in other time, you are aware with the time. It's not like I'm pausing it. No. So let me ask you to do this in 15 minutes. while waiting for you working on that, let me start working on this also. But don't get discouraged if you are not done yet. Just continue working on that. Okay, this should take you around 14 minutes to do for number 8 and number 9. Okay, before I go on, any one of you get this?
I did.
I
Okay.
did too.
Okay, great. This is actually the most tedious one for the whole test.
Good.
Remember, right, like we did this on the second week of class, and I told you if you can do this part, then your test one's supposed to be on the easy side. Okay. Now, because it's population, how do we know it's population, Thomas? Because it says so on the data. Okay, it says that it is population, right? Okay. Now, so when we do the population mean mu, that will be 2413.5 over 47. 2413.5 over 47, that is 51.35106. And then the population variance, let me give a line here so that we see the partition. That will be 47 times 163,101.75 minus 2413.5 squared over 47 squared. I get 833.31824, and then sigma equals to the square root of that. That's 28.86725. Now I rounded to 5 decimal places here, even though it says round to 3 decimal places, right? Okay, but if you want to round it to 3 decimal places, go ahead. So later on, you will rewrite this as 51.351, and this one here as 28.867. Okay, I hope you get the same with me so far. I mean, I may make a mistake too. Don't trust me too much. But the thing is, like, there are at least two of you get exactly the same thing with mine. So very likely we are okay. Now then, number 9. From number 8, what is the interval within twice standard deviations of the mean? So the lower fence equals to the mean minus twice the standard deviation. And the upper fence is mu plus twice standard deviation. That's 51.351 plus 2 times 28.867. I get negative 6.383. That's for the lower fence. The upper fence, I get 109 something. So the usual interval is from negative 6.383, nobody get negative, right? And then up to 109.085. When you compare with the original data here, the smallest one is still in the interval, the highest, the maximum 100.5 still in the interval. So we don't have outlier. No outlier. Okay, I just hope I don't make any miscomputation there though. Now, before I go on with number 10, let me give you some supplementary knowledge. Let me do it way below that and as an extra. In my class, usual interval is defined to be the interval within twice standard deviation of the mean. So it's either, let's say we have sample, so it will be from the sample mean minus twice standard deviation up to sample mean plus twice standard deviation. That's for the sample case. Or if you have population case, that will be from the mu minus twice standard deviation up to mu plus twice population standard deviation. That's in my class. Now this is what we do. We use this. Maybe I use blue. We use this definition especially when the sample size or population size is at least 30. Okay, now what is the difference between what I do and textbook? Our textbook defines usual interval as the interval from 1.5 interquartile range below Q1 to 1.5 interquartile range to above Q1. I'm sorry, above Q3. So as if I'm saying the following. Okay, we have Q1 and Q3, right? Now the distance between Q1 and Q3 is called interquartile range. Interquartile range. Now then, the interval, the usual interval will be 1.5 interquartile range less than Q1. So this is Q1 minus 1.5 interquartile range all the way to Q3 plus 1.5 interquartile range. Okay, that's how our textbook define usual interval originally, even though starting from chapter 6, our textbook defines usual interval the way we did it above. So I'm not making up stories as if like I just don't like our textbook definition. No, it's like our textbook defined it differently, originally different from mine, and then starting from chapter 6, all of a sudden they have the same opinion with me when it comes to usual interval. Okay, now, but we usually use this green color one when the sample size is less than 30. Okay, let me change this to blue here. Okay, we may use this definition when the n is less than 30 when it is sample. Okay, now let's try to apply this to our situation above. Okay, notice that the one in green is not the one I teach, and I just show you how to do this according to our textbook. In case that you tutor somebody else later on, in case you tutor a student not from my own class, and that student's instructor happened to follow the usual interval from our textbook. Okay, now let's see our first quartile in my question. In our question above, the first quartile is, as I remember, 20.5. Let me check. Yeah, 20.5, and then third quartile 76. Third quartile is 76. Okay, so what is the interquartile range? That will be 76 minus 20.5. That will be 45.5. Now, 1.5 times that interquartile range will be 1.5 times 45.5. That's 68.5, such that the lower fence is the first quartile minus that 1.5 times interquartile range. That's 20.5 minus 68 point. Why is it? No, 68.25. My bad. 68.25. I get negative 47 something, while the upper fence will be the third quartile plus 1.5 times interquartile range. That will be 76 plus 68.25. That will be 144. So the usual interval according to this definition, is negative 47 something to 144 something. Okay, now the thing is, this method is actually not really appropriate, to apply to our data, especially because our data is already more than 30. Okay, our data size, the population size is already more than 30. But if you take a look, using this result, using this usual interval, do we have any outlier? Notice that the smallest data we have is 1, and the highest data we have is 100.5, right? In other words, if you compare to the original data, we still come up with the conclusion that there's no outlier. In other words, even though the method of computing usual interval are different, most of the time, the outliers being resulted from here will be the same. Okay, most of the time. Now, why is it, Thomas, that we have different definition for usual interval? It has something to do with, is it easy to find Q1 and Q3 if you have a large data? Let's say if you have like 3,000 data. When you have 3,000 data, it's actually hard to look through those 3,000 data and then find the Q1 and Q3. Okay, so instead of go through those 3,000 data, add 1 divided by 2, that's 1,500.5 data. It's a lot of computation. So instead of computing the green one, we just go on with the blue method. Okay, so this definition that we have here, the one in blue, is the one commonly used in a lot of textbooks. Again, I'm not saying that the green one is wrong. No, this green one is actually still being used when the sample size or the population size is less than 30. Okay, but when it comes to the convenience in computing, then the definition that I use is actually better. Okay, when the population size or sample size is at least 30, which is almost the case for all my test one, then that's what we do. Okay, now coming back to here, let's see, we are done to number 9. Can you do number 10? Can you do number 10? Don't forget that the population size was 47. The data set on page 1 contains 17 female students, and 12 of these female students took the final. Only 22 male took the final. Can you set up the Venn diagram? I somehow think, did we do this problem before? I somehow think we did.
I think so.
You think so? I have something very similar. I know we did something very similar, but I don't know if it's exactly the same number. Let me see. Last week.
I think we did one with smokers last week.
Is it right? So last meeting we did one with, yeah. Let's go back even further. So, Venn diagram. Yeah, 2 circles, 3 circles, right? You see that we did this one, and then we did this one. Smokers. Oh, this is the one. This is the one. Yeah, this is the one. Exactly the same. Exactly the same. Yeah. Oh, no. This is 43 students. My bad. This is 43 students. That one is 47 students. That one is 47 students, right?
Yeah, 47.
Okay, so, but very similar. You can see it's very, very similar. Okay, let me ask you to do that then. Yeah, let me ask you to do this problem. How many minutes do you think? Will 5 minutes be good?
For the A, B, and C, or just A? Just
A, B, and C. Maybe 8 minutes then.
8 minutes, please.
Okay, 5:23. And if you need more time, of course, I give you more time.
Professor, I have a question. Isn't
Yes.
can't you do female and male, and then in the middle write how many between the two took the final?
The intersection?
Yeah.
Well, no, that's not what Venn diagram means. If you do male here and then female here, then the intersection it will be the group that is male and female at the same time.
You have the group of male and female that took the final.
Well, that's not the interpretation though. The thing is like if you write it, once you write it male, like this group here, and then this is the group of female, then the intersection must be the group that is male and female at the same time. You cannot suddenly introduce that's final, no, that's not what those cycles are.
Okay. That's what.
Okay, so either you have male and final or female and final.
Okay.
Okay.
Okay, that makes sense. Okay.
Mm-hmm, mm-hmm. Okay, let's try this then. Yes, we cannot make female and male and say the intersection is the one taking final. No, that's not that's not what Venn diagrams being interpreted. Okay, now when we say this is female, then anything inside this circle is the number of females, and the number of elements outside this yellow circle here will be the number of people who are not female. So inside the circle is the number of females. Outside of the circle is the number of not females. Okay. Now the number of elements inside the final circle is the number of people taking final. Okay. So outside of this blue circle will be the number of people not taking final. Okay, so inside will be whatever that circle says. Outside will be whatever that's not what that circle says. Okay, now that's for the interpretation. Now let's see, which number do I start with? What? Sorry, I didn't hear you clearly.
So it would be 5.
Okay, we start from where? We start from where?
Middle.
The middle one is
22 plus 5. Hold on.
This intersection here represent the number of females taking final.
12.
There are 12 of them, that's right. Okay, so there are 12 here. Now then, how many females in total? There are 17, right? 12 of them took final, so the other 5 not taking final. Okay, now only 22 male students took the final. So what should I write here?
10.
10.
10? Is it? Are you sure it's 10?
No.
It's actually 22.
I thought it was 22.
Yeah, it's 22 because it's, notice that it says only 22 male students took the final. Now it would be 10 if I didn't use the word male here.
That's
If
what.
Also, it just goes towards the female.
Yeah.
Yeah, so if it says only 22 students took the final, means 22 students take the final, then this would have been 10, right? But no, what it says here is only 22 male took the final. You see? Now, see, the number of people taking final, we don't know. The number of female taking final is 12. The number of male students took final is 22. You see this position, the position of this region here is inside final, but outside of female. You see? Okay. inside of final means this is the number of people taking final, but it's outside of female, which means this is the number of people who are not female.
And then the outside is 8.
Let's see how many outside. So 5 plus 12 plus 22
It will be
plus
39.
outside equals to 47.
It's 8.
39 plus what equals to 47? That's right, there are 8. So there will be 8 elements outside. Let me put it here. Can you tell me what this 8 represents?
People that are not taking people that are not taking finals.
How many? What not taking final?
It could be females not taking. No, not females.
It could be males. It could be males not taking final. It could be
Any other
random outliers.
No, not outliers. you were right for the first one. Okay, the number of males not taking final.
or any other gender?
Okay, outside of female, right? So it must be male, and outside of final also. So they are not taking final. So that 8 represent the number of not female not taking final. Okay, which happens to be what we need for part B. Right? Not female and not taking final. There are 8 of them out of 47. Of 47 people, 8 of them male, not taking final. Now, part C, what is the probability notation? We have the notation of selecting a female or took final. That's female 5 plus 12 plus 22 over 47. That's 39 over 47. So far, is it okay? Any question?
The wording was just tricky for the males and the 22 males, but I understand it now.
Yes, I agree with you. I didn't purposely do that though. I copy paste from somewhere as I remember.
Trick us today.
but yes, if I get rid of the word male here, it means totally different. You're right. Okay, that's the one throw us away. Okay, that's for number 10. This way, then you know when you read, you know that you need to be critical. You have critical reading, right? It means when you read, you need to pay attention to those little details. Female, male, took final, didn't take final. Okay, let's go on to number 11. Number 11 supposed to be something you know. Number 11, let me give you 5 minutes for this. This question can be so hard, but can be so easy at the same time. Suppose we have these numbers, n is 38, the sum of x is this, the sum of x squared equals to this. Use proper symbol and compute the mean and standard deviation of the data. Okay, actually the first big question is it population or sample?
Sample,
How do you know?
lowercase n.
That's right, that's lowercase n. That if earlier the word male thrown you off, right now it's the one letter. That's lowercase n. That's sample size. Okay, if that would capital N, that will be population size. You see that one, it's the same letter. One of them is capital, the other one is lowercase. It can throw you off so badly right away. But once you know that, then you basically apply the formulas for each, right? And once we know that sample size, then the sample will be for sample mean, and the variance will be S squared. Once you compute that S squared, then you compute the S. Okay, let me ask you to do that. 536, right? Make it 537. Okay, let me start with computation. I did 872.55405. Thomas, how many decimal places should I make it?
5.
5 decimal places, unless otherwise said. This is square root of 872.55405. This is 29.539025. Okay, that's for number 11. Any questions so far?
We just rounded the first one, correct?
The first one, what do you mean by the first one?
51.
The 51 happened to be precise number. Is it right? 1938 divided by 38. Yeah, that's happened to be precisely 51. Okay. 193 divided by 38. That is exactly 51. Okay, let's go on with the next one. Let me give you 10 minutes for this. Hold on. Let me make it a bit smaller so that it fits my place. Okay, let me give you 10 minutes for this. Together with your break, we come back at 6 o'clock.
Professor, where can I find this test so I could print it? Which one? Oh, never mind. I just see the title.
Yeah, and actually I posted at the discussion from last Wednesday. So you go to March the 3rd discussion. Okay, and one of the file is Spring 20 there. You can print it there also.
Thank you.
Yeah, we come back at 6 o'clock, 6 p.m. With this question done. Okay. This should take you 10 minutes plus 10 minutes break. So let's take 10 minutes break first. Okay, let's start. Some extra information that we need to leave our final answer in simplified fraction. So whatever the answer we get later on, we will reduce or simplify. Okay, suppose one element is randomly selected from the diagram. Find probability of getting someone from B. 10 plus 14 plus 5 plus 3, that will be 32 over 100. Then you reduce, I can reduce by 4, I believe, so 8 over 25. Number B, what is the probability of A intersection C? How many elements in A and C at the same time?
7 plus 5.
Louder, please.
7 plus 5.
7 plus 5, that's right. So that will be 12 over 100 reduced by 4, that will be 3 over 25. How about B union C?
10 plus 14 plus 5 plus 3 plus 7 plus 22 is 61.
Plus equals to what?
61.
Equals to 61 over 100. But this is the simplest one already. Okay, good. And how about not A but B? Outside of A but inside of B. How many of them?
14 plus 3.
That's correct. Good. You start getting used to it. And this is the simplest also. So that's the final answer. How about in B or outside of C? In B, 10 plus 14 plus 5 plus 3, or outside of C? The one in B or outside of C? Outside of C are these. Because it is an or, then as long as it is shaded once, at least once, then we count it in. So we are not counting 23 and 16 yet. So that's 32, 55, 71 over 100. Okay. Now, how about part F? Not A and not B. Not A refer to these, and not B outside of B refers to these. Because it is an and, what number are those? How many elements outside of A and also outside of B?
23, 22.
23 plus 22, so there are 45 out of 100, which we simplify by 5, that's 9 over 20. Okay, furthermore, part G, probability of outside of B, or outside of C. Outside of C is an or. Outside of B, that's 23 plus 7 plus 22 plus 16. Or outside of C, 23 already counted, 16 already counted. I need to have 10 and 14. So how many here? That's 30, 52, 68, 78, 92. Reduced by 4, that's 0.3 over 25. Okay, any questions so far?
No, just I always get turned around with the not in B, and let's see, the last one I always get a little confused on.
The last one, Not in B refers to outside of B, right? So outside of B are this guy, this guy, this guy, and this guy. Yeah, 23 and 7 and 22 and 16.
But I like how you did those first and then moved on to the C, not in C. It helps me out.
Oh, okay. Actually, it's union, so you do either one. I think the one that that I think helpful is that I feel that it's quite helpful to have different highlights. You know, we don't have this in classroom though. In classroom, I have different color of markers, right? But I cannot highlight. I cannot highlight. So it's actually quite helpful to have this.
On our test, do you mind if we do highlights and everything?
I don't mind. I don't mind. Just make sure that you don't get confused, though.
Okay.
Yeah, make sure you don't get confused. In class, when I don't have highlight, then I use my marker. I circle them. So outside of B are outside of B. Assume this is my class, right? In classroom. So then I circle them in because I cannot highlight that. And then outside of C will be, then I use another color. Outside of C will be this guy and this guy and then this guy and then this guy. And then I ask them, okay, it's a union. So at least if you circle it at least once, you count it in. You know. But make sure that you can erase that though. You know, because if, for example, for part B, if you already do circles and you cannot erase that, then for the rest of the question, you have to rewrite or redraw the Venn diagram again. You see what I mean? The good thing with this is like I use a computer, so I can easily erase that. Right. Okay, let me go on with number 13. Number 13. Let me enlarge that a little bit. Okay, let me ask you to do this. Somehow I think we did this problem before, but maybe different numbers. Okay, but this one, leave your answer in 4 decimal places. Okay, for A to C, you need to write the notation first and then compute the probability. Okay, let me give you 8 minutes for this. So we come back at 6:16. Yeah, you need to get the total first. Okay, I worked out some of them already. Please take a look. So part A, B, and C. Part D, probability of interdisciplinary outside of no expertise. Outside of no expertise. So basically have some expertise. Okay, not expert, but have know something. Okay, in the interdisciplinary, inside of this, but outside of norm. It's intersection, right? So what is this? It's intersection, so it's the one shaded twice. That will be 9 plus 21 plus 14 over 262. That's 44 over 262. That's, let me write it down here, 0.1679 in 4 decimal places. Part A, probability of non-STEM, so outside of STEM, with no technical writing expertise at all. Outside of STEM refers to this. That's outside of STEM. And no technical expertise. So that would be 20 plus 15, huh? Over 262, that's 35 over 262. That's 0.13358, so that's 6. If we round it to 4 decimal places. Okay, the next couple questions, I will just go ahead do that. Number part F. If 3 participants are selected from that group, find the probability of selecting 3 intermediate level students. You don't need to write the notation. You don't need to write the notation, just go ahead with computation. 3 participants from intermediate level. How many intermediate students? There are 70, right? But you need 3 of them. So 70 over 262 times 69 over 261 times 68 over 260. Now, how do you compute this though using your calculator? Do not change each fraction to decimal. No, don't do that. That's not how you do it. Compute without converting it to decimal first. We'll do the following. So for example, I will do 70 over 262 times right away 69 over 261 times right away 68 over 260. Okay, now then you look at that, then you round to 4 decimal places. Do not round each, do not do this, don't do this. Don't do this. You change it to decimal, you already round it, change it to decimal, you already round it, change it to decimal, you already round it, and then when you multiply, that will be rounding error on the top of rounding error. It's compounded rounding error. Now, instead of doing that, we use calculator. We just hit all those numbers at once in, and you will get what? 0.0185, right? 0.0185. 0.01847. So round to 4 decimal places, that 5. Okay, now part G, 3 non-stem, probability 3 outside of stem. So all of them not in stem. Now, how many people not in stem? The number of elements not in stem is 138 plus 59, right? That's 197. Okay, so the first person not in stem, 197 over 262. The second person also not in stem, 196 over 261. The third person not in stem, 195 over 260. Then we calculate using our calculator. You punch all of them at once. So that's the first fraction multiplied by the second fraction multiplied by the third fraction. Zero 0.42348, so 4235. 0.4235. Part H, find the probability at least one beginning. At least one beginning. How many beginning level? 68. Okay. So, but at least one beginning is the complement of no beginning. That is 1 minus probability no beginning. Now, how many people not in beginning? How many people not in beginning is this guy, this guy, this guy, right? So 43 plus 70 plus 81, that's 194. It's 194. Okay, so here it will be 1 minus 194 out of 262, not beginning. 193 over 261, not beginning. 192 over 260, not beginning. 1 minus. I get 1 minus 0.4043, which will be 0.59566. Now that's for number 13 compound events. The last question, number 14. That's the inclusive exclusive formula, right? Let me just go ahead and do that. So probability of the union equals to probability of A plus probability of B minus probability of D intersection. Then I plug in numbers. Probability of A is probability of the union 0.97. Probability of B 0.85. I'm sorry, probability of A 0.85. Probability of B, the one we look for, minus probability of the intersection 0.54. So this is 0.97 equals to 0.31 plus probability of B. Subtract by 0.31 both sides. We will get 0.66. That is probability of B. Okay, so today we already finished at least 3 tests though in the past, but we did number 1 to number 9 for 2 tests, and then the next meeting we did other parts, and then for the next test we did other parts. The next day we did other parts. Now today we finish 1 whole test. Okay, so instead of working on those topic by topic, we also have work on this by all tests for the whole test. Now you should practice from my other test though. Okay, you have how many? You have 1 weekend to do this. When is your next test? If you see the discussion board today, I mentioned that our next test is next Wednesday, not this Wednesday, next Wednesday. So test 1 will be test 1 will be on March the 17th, 9 days from now. Okay, and it will cover up to basically up to compound event. Okay, up to section 5.3. Section 5.3. But if I were you, I will not study from the book anymore. I mean, studying from the book should be something we did first and then study from my old tests, right? But if you try to study from the book at this point to study all the material from the book, it's a bit too late. Just attack my old test right away. Okay, and the lecture, the question and answer sessions we have done in the last 2 weeks basically cover a lot already. Okay, now the next thing we will do, supposed to be the material today, but I rather spend some time with old test so that you get used to it. We will do 5.4. That's on conditional probability.
Are we doing that today or Wednesday?
Repeat again.
We're doing the conditional probability today or on Wednesday?
We'll do it today, the easy one, and then on Wednesday we'll do more. But I hope you watch the lecture video. That's lesson 8.
Yeah, so you want us to watch it, the other one by the 10th?
Actually, you're supposed to have watched it because today is meeting number 8. Yeah, today's meeting number 8, so you're supposed to have watched it by today. But the material is actually on the easy side. So I can say that if you watch your lesson 8, okay, that's basically whatever we need to cover. Lesson 9, which we will do on this Wednesday, it's on 5.5. That's actually quite difficult. Make sure you watch that by this Wednesday though. Okay, lesson 9. This is lesson 8, which is the lesson for today supposedly. But this is again like if you watch the lesson 8 video, you should be okay already. Now conditional probability. Okay, definition, which I said in my lecture, but let me mention that again here. Probability of event A to occur knowing, or they usually use the word given, event B occur is denoted by probability of A given B. Okay, so the first number is the event we are looking for, desired event. And then the event after that vertical line, that's a vertical line. That's not a diagonal line. That's a vertical line. And this B that's written after the vertical line is the condition. Now let me start working on this with, let's use problem from what we had before. Let's say I use the Venn diagram we have before from here. Let's use this Venn diagram.
This wouldn't apply to the questions in the quiz, right?
Repeat again.
The quiz didn't it didn't contain this material, right?
The quiz or test.
Quiz 2-4.
Quiz 2 to 4, as I know, it doesn't have conditional probability.
Okay, yeah, I'm just making sure.
But let me check again.
Because I was stuck on one of the questions, and I think this could be a way to solve it.
Let me see again. Because there was one time I gave a quiz, and it turns out that that quiz has conditional unintentionally. But it's easy to do. So let me see. Let me see. No. This one is not in quiz 2, 3, 4. So yeah, not in quiz 2, 3, 4. Then it will be in your quiz 5, 6, 7, which I plan to give out for next week. So after your test during that weekend, you have something to do. Okay, suppose we have this Venn diagram, okay, and we will select one element at random, one element from the Venn diagram at random. What is the probability of selecting a female? We know there were 47 people there, right? I took this question from our the test that we took earlier. We did earlier, number 10. I just borrowed the Venn diagram. Okay, there are 47 people there. How many female? There are 17?
17.
17 over 47. Now, suppose I change the question to be, find the probability that we select a female knowing that person took final. So instead of selecting from the whole Venn diagram out of 47 people, instead of selecting from the whole Venn diagram, we only select from those people taking final, because that's the condition. Knowing that person taking final, what is the probability that person is a female? Okay, now we usually do from the denominator first. Okay, how many people took final? 12 plus 22. There were 34 people taking final. Now, of those 34 people, how many of them female? 12. So this will be 12 over 34, which we can reduce. Or you can change it to decimal also, either way. Okay, so we count the condition first. Okay, of those people taking final, there are 34 of them. How many of them female? Now let's reverse the order. What is the probability of taking final knowing that person is female? So start with the condition. How many female?
17.
17, that's 5 plus 12. Now, of those 17 female, how many of them took final?
12.
12. So this will be 12 over 17. Okay, now from part B and C, you see if you reverse the condition and the desired event, if you reverse that, then the outcome may be different. Okay, very likely different. In other words, in general, probability of A given B in general is not the same to probability of B given A. Okay, that's in general. Now, I did the easy part, B and C. You try the slightly harder one. Not that hard. I don't think this is a lot harder. Of course, you need to think, right? What is the probability of selecting a female given that person, knowing that person did not take final? And part E, find the probability of that person did not take final, knowing that person is not a female. Okay, let me give you maybe 2 or 3 minutes for this. Okay, let's start. For part D, we start with the condition. How many people not taking final?
8.
8 and 5. Right, there are 13 people not taking final.
Oh, yeah, my bad.
Okay, then of these 13 people, how many of them female? 5, right? Now you will see that the number on the numerator must be part of the number on the denominator, because we basically select from this, right? How many of these actually satisfy the desired effect? Okay. Now let's go on with the last question here. How many not female? 8 plus 22, there are 30 not female. Of these 30 not female, how many of them not taking final? There are 8 of them, right? So reduced by 2, that's 4 over 15. Okay, I hope you find this to be easy so far. Now, some of my old tests, some of my previous tests includes conditional probability with the Venn diagram or with contingency table. Starting from a couple years ago, I decided not to ask the conditional probability problem in my test 1. But if you go like around 4 or 5 years ago or more, then you may see some of my test 1 includes conditional probability. Okay. What happened was this: there was a couple semester I asked them, do you want to include this in the test? And then they say, oh yeah, let's put it in test 1. It seems to be easy, you know. But recently I have more and more students, they don't really study that much, or even when they were in class, their minds not in class. So whatever you ask them, do you want this? They will always say no. I mean, even if I ask them, do you want to pass the class? They will answer no even before I finish that sentence. They will just say no to me all the time. No, that's why I said, okay, oh, you don't want to include this easy. The thing is that those students who pay attention, they found this to be easy, and they say, let's put it into test 1. It's easy anyway. Okay, let's go on with another type of conditional probability problem. We still select one element at random, and let's use the 3 circles we get from our Venn diagram here. Give me a second. I'll screenshot that. Oops. Suppose we have that Venn diagram. Okay, now let's see part A. Select one person at random or one element at random. Find the probability of selecting A given in B. Part B, find probability of getting B given not C. Probability of not C given not A. Can you try to do this? 3 minutes. Okay, let's start. Probability of getting an element from A given it is in B. So the denominator will be the number of elements in B, 10 plus 14 plus 5 plus 3, which is 32. Now of these 32 elements, how many of them in A? Of those elements in B, that's the condition, right?
That's fine.
How many of them in A? That's 10 plus 5, that's right. So that will be 10 plus 5 over that those numbers. That will be 15 over 32. Part B, what is the probability of getting an element in B knowing it is outside of C? Outside of C are these numbers. Those are outside of C's. 23 plus 16 plus 10 plus 14. That's 63. Now, of these 63 elements, how many of them in B? The one in B are this guy and this guy, right? So there are 24 elements. That's 10 plus 14. That's 24 elements in B of those outside of C. I can reduce by 3. And then the last part, part C, find the probability not in C given it is not in A. Let's see the one not in A first. Not in A are this guy, this guy, this guy, this guy. So there are 23 plus 22 plus 3 plus 14 elements not in A. How many of these? 26, 40, 62. Of these 62 elements not in A, how many of them not in C? This guy not in C, this guy also not in C. That's 37 over 62. I cannot simplify that further. Okay, now of course we can also work on that with contingency table. Let's do 1 or 2 problems and then I'll let you go. So, let's take this one. Example 3. Suppose we have this Venn diagram here. Okay, part A, find the probability of selecting someone with no expertise at all, given that person is in STEM. So we select from those in STEM. How many people in STEM? There are 65 people in STEM. Right now, of those 65 people in STEM, how many of them has no technical expertise at all in technical writing? There are 8 of them. Okay, of these 65 people, which they already add, we already did that addition. Okay, of that 65 people, 8 of them without technical writing expertise. How about probability of, let's say, not social science given that person has intermediate level of technical writing expertise. We see how many people have intermediate level of technical writing. There are 70 of them, right? There are 70 people with intermediate technical writing. Now, of these 70 people, how many of them not in social science?
32.
32. How do you get that? 11 plus 21. Okay, 11 plus 21. Now, I will not write 32 right away, especially because I know I may study from here, right? So I write where I get those numbers before I compute that further. Okay, this way then when you study at home later on, let's say a couple of days from now, you know where we get that 32 from. Okay, now I will stop here. What we will do on this Wednesday? Wednesday, we will do the conditional probability still. But we will do the one without Venn diagram and without contingency table. Now that's from 5.4, and then I will continue with 5.5. 5.5 is a very long section. It's a very long section. Okay, so I would like you to please watch. Please watch lesson 9. Where do we find lesson 9, Thomas? Because in announcement 3, it's only up to lesson 8. You can see announcement 4. Okay, announcement 4, we have lesson 9 already. Lesson 9 is the first half of 5.5, and lesson 10 is the second half of 5.5. So I basically spent like 1 week for that one section 5.5. Okay, I hope that with you watching those videos already, then I can do even more problem. What I plan to do is 5.5, I'll do problem from the book, and 5.6, I do problems from my test. Okay, my old test 2. Okay, but the material for your test 1 already finished earlier today. Okay, then that's for today. See you on Wednesday.